In this video, we will look at some trigonometrical identities. So let's jump into it, and first I will just draw here a right triangle. So here is our right angle, and as usual, let's denote this angle with alpha, and its sides will be A, B, and C. So the first one is the Pythagorean theorem, which says that the sum of the squares of the legs is equal to the square of the hypotenuse, and we will just write this down. So a squared plus b squared equals c squared, and what we will do is just dividing by c squared, because we will see that sine and cosine will appear here. So a squared over c squared, we can write this as a over c squared, plus similarly this we can write as b over c squared, and c squared over c squared is 1. And as you can see here, these fractions are appearing. So a over c, this is the adjacent side of alpha over the hypotenuse, which is the cosine of alpha, and this is on the power of 2, and this we can write as this. So cosine of alpha to the power of 2 can be written as cosine squared alpha. So the exponent can be written here, and also for sine as well. So in the followings we will use this notation. And so b over c is the opponent side of alpha over the hypotenuse, which is the sine of alpha, and this is on the power of 2, so we can write as sine squared alpha, and this is 1. So this is our first identity, which is perhaps the most useful, because if we know angles sine or cosine, then we can calculate the other trigonometrical expression. The next group of identities is related to the complement angles. And what a complement angle means is that if we have an angle like here alpha, then the complement angle of alpha is this one here, which is pi over 2 if we calculating in radian, minus alpha, or in degrees 90 degrees minus alpha, if alpha is given in degrees. And we saw in the previous video that if we have sine of alpha, then this is equal to the cosine of the complement angle. So we can write this as cosine of pi over 2 minus alpha. And similarly, if we have cosine of alpha, then it is equal to the sine of the complement angle. And if we divide sine of alpha by cosine of alpha, then we get tangent of alpha, and we will get cosine of the complement angle divided by the sine of the complement angle, which is the cotangent of the complement angle. And one more, if we take the reciprocal of this equation, then we get that cotangent of alpha is equal to the tangent of the complement angle. So these are the other identities which is dealing with the complement angles. And let's continue with the so-called Ptolemy's identities, which will be our third group of identities. And this is dealing with the sine and cosine of sum or subtraction of angles. So this is what Ptolemy's identities is calculating. So we are taking the sine of, let's say, alpha plus beta, so sum of two angles, and this can be expressed by the separate sine alpha, sine beta, cosine of alpha, and cosine of beta. So it will be sine of alpha times cosine of beta plus cosine of alpha times sine of beta. Similarly, we can calculate the cosine of two angles sum, and this will be cosine of alpha times cosine of beta minus sine of alpha times sine of beta. And we are taking the sine of alpha minus beta, so if we have a subtraction of two angles, then this can be written as sine of alpha times cosine of beta minus cosine of alpha times sine of beta. And the fourth one in this group of identities is the cosine of two angles subtraction. So cosine of alpha minus beta can be written as cosine of alpha times cosine of beta plus sine of alpha times sine of beta. So you don't have to memorize these identities. It is good if you know the first and the second group of identities because these are the most important ones. But the third type of identities is not crucial for you to know. So in this video, we looked at the most important trigonometrical identities.